Now let us discuss the compounds of hydrogen, and the most important one they are called hydrides. See, hydrides are the binary compounds which hydrogen forms with almost all elements except noble gases. Except noble gases, remember. Now these hydrides are of three types. They are of three types. The first category is called of ionic hydrides. The ionic hydrides are the hydrides which hydrogen forms with group 1, 2 elements. Let me give you an idea like sodium hydride, lithium hydride, magnesium hydride, calcium hydride, which is also called hydrolith. So these are all the hydrogen, the compounds, binary compounds which it forms with alkalis or with alkaline elements or metals are called ionic hydrides. Now why we call them ionic? The reason is because the bond is ionic. There is ionic bond between metal and hydrogen. That's most important. Now all these hydrides are crystalline ionic hydrides. Now all of these are non-volatile, or maybe they can be volatile, and but most of them are non-volatile solids. They are non-conductive in solid state, but what we find them is that they become what conductive when they are taken in molten state. Yes, if we take sodium hydride and we are doing its electrolysis, remember it breaks down into Na plus and H minus, and this H minus, let me about this one to explain you all this. Then this H minus approaches anode, and there it forms what hydrogen and releases electron. It gets oxidized to hydrogen. Another most important thing is that these hydrides, when added to water, results in the formation of corresponding metal hydroxide and hydrogen gases being released. Now lithium hydrides in this are one of the most important hydrides we have. They combine with AlCl3 or Al2Cl6 to form lithium aluminium hydride, one of the most important reducing agent in organic chemistry along with lithium chloride. This lithium hydride also combines with boron, a diboron hydride or diborane, to forms lithium boron hydride. So these are what we have, the ionic hydrides. Now let us see the second type of hydrides, which are called covalent hydrides. Now what are covalent hydrides? Compounds of hydrogen with p block elements are called covalent hydrides. Why? Because bond between them is covalent. Now what you need to remember is that these covalent hydrides, which the hydrogen forms with the p block elements, are of three types. The first one is called electron deficient hydrides, which hydrogen forms with group 13 elements. Let me give an idea. Like we have B2H6 or ALH3, etc. Now in these, octet is not complete. Once the octet is not complete, they always are electron deficient. So they work as Lewis acids and they are called electron deficient hydrides. Now the second category is electron precise hydrides. They are the ones which hydrogen forms with group 14 elements. Let me give an example like methane, selene, germane, etc. They have exact octet, no lone pair. So they are neither electron deficient nor they are electron rich because they don't have any lone pairs. That's why they are called electron precise hydrides. Then the third category is of electron rich hydrides. Electron rich hydrides are the ones which hydrogen forms with group 15 to 17. Let me give you an example like ammonia, like water, like H2S, like HCl, etc. In these we know that nitrogen is having one lone pair with it, oxygen has having two lone pairs, sulfur is having two lone pairs, chlorine is having three lone pairs. Now all these lone pairs makes them electron rich. So they work as Lewis bases. So that's how we have three different types of covalent hydrides. Now being covalent in nature, they have a perfect structures because we know that covalent bonds are what? Rigid bonds. We have done in the bonding. So they have perfect shapes according to the hybridization of the central element that we already know we have done in case of in the chemical bonding chapter. The third category of hydrides are called metallic hydrides or interstitial hydrides or non-stoichiometric hydrides. Now these are the hydrides which hydrogen forms with D block and F block elements. So the compound it forms with the D and F block metals are called interstitial or metallic hydrides. Now why we call them interstitial? The reason is because it was earlier we used to believe that since in these metals we have lot of what? Interstitial spaces, so which are being occupied by hydrogen. We used to call their combinations with these metals as interstitial hydrides. Now these compounds are non-stoichiometric, so the ratio is not fixed like we have lanthanum hydride 2.87, titanium hydride 1.5 to 1.8, it can vary in any of these ratios. Nickel hydride 0.6 to 0.7, so like these are not fixed, the ratios are not fixed. So the law of constant composition doesn't hold good on these compounds. They can conduct electricity, yes, to some extent, but not as the other one we used to have in case of the ionic ones. Then the further studies have revealed that what we have got to know that except certain metals like palladium, actinium, lanthanum, etc. In all others, what we find is that the structure, the solid structure, crystalline structure of the metal hydride gets changed and it becomes different from what the usual metal was used to have. So it means what? It's not just that the hydrogens are occupying these interstitial voids, to somehow they get also involved in the orbital overlapping and in the bonding. Then another most important thing is this, that in the D block group number 7, 8 and 9 elements doesn't combines with hydrogen. This is called hydride gap in the periodic table. Even in group 6, only chromium forms chromium hydride, rest no combines with hydrogen. So that's very different behavior we have. Now these you need to know the metals like palladium, platinum, etc. can accommodate hydrogen to a great extent in their crystal lattices, and that is why they are mainly used for hydrogen storage purpose. So this is what we have, the interstitial or metallic hydrides.